Well, howdy, cowgirls and cowboys. This is Mr. Kushon with the Deer Valley Online Learning Program. Today we are going to be looking at ASA Triangle Congruence. Use appropriate tools to create a triangle that is congruent to triangle ABC. All right, so when I look at this, I'm looking, hey, how am I supposed to do this if I don't have side length AB, if I don't have side length CA, and I don't have angle A? Well, angle A, we could use the Triangle Sum Theorem to figure out what that is, but we certainly don't know what A, B, and AC are. So is this even possible? Let's try it. Let's see what we can do. Appropriate tools. So I'm thinking that that's probably going to be a couple things. Probably going to need a ruler and a protractor. And voila, movie magic. There they are. So looks like the first thing we need to do is create a 5 centimeter long line. So that's pretty easy to do. I'm just going to use this little ruler here. So now I've got a 5 centimeter long line. I have no more use for the ruler for now. All right, let's get the protractor out here. I need to create a 30-degree angle. All right, so I got that perfectly lined up. 30 degrees on my protractor. It's going to be right here. So I just got to draw a line through that. And I'm not going to worry about the length just yet. All right, 56-degree angle. It's going to be tight. It's like right here. It's going to be like right there. So I'm just going to make a line through that point. Alright, so now I'll just get rid of... What I have to do here is just bring this down a little bit because I had to draw it longer. I wasn't given the thing, so I'll bring it right down there. Alright, now we'll compare. So it looks like we did it, and I'm pretty proud because I didn't think we were going to be able to do it with just that limited information. All we had was the 30 degrees here. Highlighter. All we had was the 30 degrees here. We had 5 centimeters and 56 degrees. We don't need to know this, right, to prove that it's congruent. We didn't need to know this, and we didn't need to know that. All we needed was this angle, we needed that side, and we needed this angle to prove congruence. Now, there's a reason why I just wrote down ASA. And that's because this proof that we're about to do is actually called angle side angle. So we don't need to be shown all 6 corresponding parts of the triangle. We can do it with just 3 if we know the angle, included side, and angle. Let's investigate this a little more. So in the last lesson we learned that congruent triangles have 6 corresponding congruent parts. But as we just learned, as we just experienced, we don't have to know all 6 parts. We actually, in many cases, only have to know 3. So the one that we just discovered was called the ASA Triangle Congruence Theorem. So what we just noticed was that when we have 2 angles, like in this case 30 and 56, and we get the 30 and the 56 here, and we have what's called the included side, meaning the side that's in between those 2 angles, if those are congruent, then the triangles are congruent. So we don't need to know AC or AB. We don't need to know angle A. That's not necessary. All we need is these 3, the angle, side, angle. Now that we have this, we can figure out problems that would have stumped us last lesson. Is triangle ABC congruent to triangle DEF? Well, yesterday at this time we might have said we don't know, because we don't know a lot of information here, but we don't have to do that today. We can figure it out without all the information. So if we look at this triangle here, it does appear that, or these triangles, triangle ABC, C corresponds to F, and it also looks like AC corresponds to line segment DF. So if we can figure out what this one is, what this angle is, we could use ASA to determine congruence. So that shouldn't be that hard. We can use the Triangle Sum Theorem. We know that angle D plus angle E plus angle F have to equal 180. And we know that angle E is 74 degrees and angle F is 61 degrees. All right, we know that 74 plus 61 is 135. So now we've got 135 plus angle D, whatever that is, must be 180. We've got a little algebra problem here that we can solve. Subtract 135 from both sides. Oh, darn it, that's the plus sign. 135, that's going to be 45. So we know that angle D equals 45. We'll put that right here. And now it looks like we can judge congruence because we have 45 here, 45 there. So we have angle, side, angle, congruence, ASA. And that is congruent to ASA. So, yes. All right, so I'm going to do this one a little quicker. 62 and 62. So JL, line segment JL, corresponds to line segment PM. So now we've just got to see if these are going to match up. And the angles are 31 and 110. So let's find out what P is. We got to do 31 plus 38. And I know that that one's going to be 69. 180 minus 69 is 110 degrees. So this is 110 degrees. So it looks like once again we have ASA congruence because we've got the two angles and the included side, which is the side in between the two angles. That's going to be congruent, all three of them. So yes. And since we've done a couple of them, I wanted to give you guys a chance to do these and then see if you are correct. All right, so hopefully at this point you've done these and you have an idea of which ones are congruent, and if they are, why. So this first one, they just have the angle markings here. You can tell that with this being a straight line, with BC being a straight line, and AD being a perpendicular bisector of those two lines, you can tell because the BD is the same as DC. We know that angle ADB must be a right angle. So here, once again, we have the side angle sides, the two sides, and the included angles are also congruent. So this number 5 we don't know what the numbers are, but it doesn't matter. We got the markings. Yes, they are congruent by the angle side angle theorem. All right, now number 6, hopefully you realized that we're given the 1 inch, so our included side is the 1 inch right there, and then our angles are 38 in this case, and 67 for STU, for triangle STU. But for 6, when you do 72 plus 38, you're going to get 110, which means that angle R must be 70 degrees. And then you have, I'm going to do it a different color because it's not the same. R and U are corresponding, yet they are not equivalent. They are not congruent. So this one you should have said no, they are not congruent. There's a couple other problems that you can do, and then when you undo, the answers are already going to be on the screen, so make sure you have the answers before you hit pause or unpause. All right, there's your solutions. Number 3 was a yes. Number 4 was a big no. All right, so let's have some fun. It's proof time. Now, when you're doing a proof like this, I like to start out just informally and see how I'm going to do this. I need to prove that triangle RST is congruent to triangle VUT. And for that, I'm going to use angle side angle. So I know right away, because they tell me, that S and U are right angles. So there's an angle right there. There's a right angle, and there's another right angle. All right, now it says that RV bisects SU, which means that ST and TU are the same. So I've got angle and side. And now the last thing I need to do here is find the other angles that are corresponding and determine if they're congruent. And they definitely are. That's going to be angle T, and I just wanted one arch there. Angle RTS, and then angle UTV. They're vertical angles, so those have to be congruent. So we have our ASA right there. So now I just got to write up my statements here. So I'm going to start with what's given. Now they're right angles, so that means they're congruent. They both equal 90 degrees. Just put that in there real quick. All right, and now I can go after the other one it gives me, which is RV bisects SU. And that tells me that ST is congruent to TU. And I know that angle RTS is congruent to angle, and I got to make sure I get the order right here. It's going to be VTU, because if you just did a 180 degree rotation around point T, R would end up where V is, S was where U would be, and then T would just stay the same. So VTU, and that's the definition of, or vertical angles theorem. And lastly, because I proved it here, with S and U being congruent, that's an angle. And then I proved that the line segments, the included side, was congruent. And then lastly, the other angle was congruent. Then the triangle must be congruent. Alright, so we're going to check in with that essential question. What must be true in order for you to use the ASA Triangle Congruence theorem to prove the triangles are congruent? Well, what you have to do is you got to have those two angles and their included side that are congruent. So you got to have, like in this case, you got to make sure that W and L are congruent, and they are. X and M are congruent, and they are, and their included side. It's got to be the included side, the side in between them, in order for you to make sure that they're congruent or not. So I'll write that down. And this poor pair of triangles over here is not feeling a whole lot of love, but we have this one here, and then obviously their side is going to be included. And because we've got parallel lines, and didn't really show you, but it has parallel lines, so that would mean that these interior angles are also the same. So again, another instance of ASA. All right, let's check out the notes. And that runs down our notes for the day. I will take my leave if you want to jot these down. Hope you guys have an excellent rest of your day. As always, just let me know if there are any questions. Looking forward to hearing from you soon. Have a great day, folks. Bye-bye.